Welcome. Welcome to the fourth class of this third week. We are going to talk about the past observation as far as the temperature is concerned. So, through this lecture today, we are going to discuss about the temperature, particularly what is the global mean temperature, the Earth's effective surface temperature, and what is the influence of greenhouse gases, and then how this temperature has been fluctuating since last several millions years. So, in that course, let us understand the concepts whatever will be covered are nature timeline. So, in this we will also talk about the galactic neighborhood in terms of Earth's origin, Earth's setup. Then we will discuss on variations of effective and surface temperature with respect to two of our neighboring planets. There we will discuss about the influence of greenhouse gases. Friends, you must be knowing that both our neighboring planets including Earth have lot of greenhouse gases in the atmosphere. So, how the presence of these greenhouse gases influence in terms of getting or giving an effective and surface temperature to that planet. Then we will talk about the global mean temperature during past 500 million years, how it has fluctuated, and particularly the evaluation of this temperature since last 60 million years. And we will also talk about any kind of change, the change in terms of surface temperature, the anomaly, and also the differential warming after 1900 and with respect to the world ocean disparity. So, what is the disparity as far as the temperature is concerned over land surface, over the oceanic surface? So, to begin with that, let us go back to the timeline as far as the nature is concerned. On the left hand side, we have put a figure where you can see the origin of our universe goes up to 13.8 billion years. Then you come up and off from there, and then somewhere 8.8 billion years before the Milky Way galaxy, the spiral arms forms. And then our one that is named as the Alpha Centauri, the Milky Way has formed. So, in that sense, then you can see the formation of solar system goes back up to 4.54 billion years since today, and then we have the earliest Earth formation, and then earliest Earth formation goes back to 4.54 billion years approximately. So, from there onwards, let us look at the figure where it is mentioned you are here. So, in this universe, this galaxy is located somewhere little far away from the center. So, what does it mean? In terms of this galactic neighborhood occurrence, it means that the galactic environment impacts habitability. At Milky Way, the galaxy's edge, our galaxy is at an edge or not, or you can say it is far from the center. It is not close to the center. So, it is at an edge. So, not near active ray sources. So, had it been closer to the center, it would have been nearer to the active gamma ray sources. So, not near galactic center with high star density and ionizing radiation. So, had it been closer to that, it would have come across high star density and ionizing radiation. So, we are safe in the sense that we are little far away from the center, we are protected from heavy or active gamma ray sources. So, this kind of loneliness in galaxy is helpful. So, how it is helpful? Because today's class we are discussing about the temperature. So, I thought to start it from there in terms of Earth's location. or in terms of Earth location within the what you say universe, and and as you see it is little far off or little at edge. So, from there, because we are going to talk about our own planet's temperature, it is very important to understand from its own origin in terms of the Earth presence or the location in the whole universe through or within our galaxy. So, now friends, if you see here, in here we are going to discuss with respect to the variation of effective and surface temperature on or in comparison to two of our neighboring planets. So, what does it mean? So, all if you see here, the inner planet is Venus and the outer planet is Mars as far as the solar system is concerned, and the third column I have mentioned here with respect to the greenhouse gases. We have dominantly the Venus has greenhouse gases which composition is dominantly carbon dioxide, whereas as far as Earth or our own planet is concerned, it is dominated by water vapor and carbon dioxide, whereas in terms of Mars it is carbon dioxide, and in terms of the atmospheric pressure you can see Earth is taken as 1 and comparatively Venus as having 90 and Mars is 0.006. Now, let us move to the fourth column where it is mentioned, fifth column where it is mentioned in terms of the albedo. What is the albedo? Albedo is the reflectivity property of the planet. So, that means whatever is the solar radiation is falling on the planet's surface, here it in terms of Venus, Earth and Mars, out of that in case of Venus 76% is reflected back. So, in comparison to Earth which is 30% and Mars which is 25%. So, Venus has a higher albedo than in comparison to Earth's surface. So, the last three are the right hand side very important, in the sense we want to discuss here or we want to talk about here as far as the temperature is concerned. Friends, look at the last third column which is the effective temperature in terms of Kelvin, the surface temperature also in terms of Kelvin, and the greenhouse gas warming in terms of degree centigrade. So, you can see, if you see with respect to Earth, we have a difference of or the greenhouse warming contribution to the tune of 33 degrees centigrade. So, that means had greenhouse gases not been present on our surface, then the effective temperature would have been less than what we are receiving there. So, that means it would have been minus 18 degree. So, without greenhouse gases, Earth would have an effective temperature of minus 18 degree instead of what we are observing today, which is 15 degree centigrade plus. So, in comparison to Earth, if we also take Venus, there you can see the greenhouse warming contribution in terms of degree centigrade is 521. It is too high because you have largest concentration in terms of dominantly the carbon dioxide present in the Venus atmosphere. So, it is giving the global warming effect to the tune of 521 degree. So, in a sense, had the greenhouse gases not been there in the Venus surface, its effective temperature would have been 229 than what it is observed now is 750. Similarly, for Mars, the greenhouse warming contribution is 8 degree centigrade. So, that means the effective temperature would have been 210 in absence of the greenhouse gases presence in the Mars atmosphere. So, it is very eminent, it is very proven, demonstrated that the greenhouse gas concentration or the greenhouse gas contribution towards warming is different for different planets, and so as our planet Earth is concerned, it is 33 degree to the tune of 33 degrees centigrade. So, without greenhouse gases, I will repeat this sentence again, without greenhouse gases, Earth would have an effective temperature of minus 18 degrees centigrade instead of the observed 15 degree centigrade plus. Why I have put plus? Because we are going to discuss, we have already started discussing on this, because Earth's average or effective temperature is warming, and this is what sets our second point. The first we discussed with respect to the presence of Earth in the galaxy. It is present at an edge, and here we are talking about the greenhouse warming contribution as far as Earth in comparison to its two neighboring planets are concerned. So, the repercussion. So, had the greenhouse gases not been there, that means Earth effective temperature would have been minus 18 degree or around that. So, had our effective temperature would have been minus 18 degree, what would happen? Then the water what we are having now in liquid form, it would have been not available to us in liquid form, it would have been available to us in solid form, a frozen form. So, life would have been difficult. So, thank God we have the presence of greenhouse gases, but the point is the greenhouse gas concentration has to be there within that limit. If we are increasing, we are going to learn, or we all know now. So, but quantification are the things we are going to learn. So, we are going to throw a lot of greenhouse gases to the atmosphere, which is contributing towards warming. So, we need greenhouse gases in an appropriate proportion, in an appropriate concentration. If it is more than that, then it is going to be again negative for the humankind. That is what we are going to discuss in our next slides. So, friends, now let us talk about the fluctuation or variation in terms of the global mean temperature in last or the past 500 million, or you say half billion. Friends, all this simple calculation you understand. 10 lakh is 1 million, 1000 million is 1 billion. Here we are talking about the half billion, and in the second slide we discuss Earth's origin is something about 4.54 billion. So, we are just talking about the fluctuation as far as the global mean temperature is concerned over past or immediate last 500 million years, or you say immediate past half billion years. I am sorry, I have missed to type in the slide, in the title slide 500 million years. Please add it to there. So, it has to be 500 million years. So, now look at this. Global mean temperature has fluctuated between ice house and hot house conditions during the past 500 billion years. So, during the past 0.5 billion year, which you say 500 million years. Look at the curve, and the y axis, the curve says the temperature variation between 10 degree to 30 degree centigrade. In the last class, in the last slide, I just mentioned that the Earth's average temperature is somewhere slightly more than 15 degree centigrade. Please remember the absolute term, so that it will be very useful for us to compare and contrast with. So, current day Earth's temperature, Earth's average temperature is somewhere 15 degree plus, and then now you see the fluctuation, the global mean temperature fluctuation over past 500 million years. It has fluctuated, it has been fluctuating between 10 degree to 30 degree. You can see the curve is altering between ice houses. Down below you have written it in terms of ice altered with the warm. So, you can see here ice warm kind of situation, and on the upper side the number of years in terms of million years have been written, and the geological era which represents those duration of the year in terms of million years. 4 major hot house periods have been seen a largely ice free planet. You can see here you have a planet where ice deposition is there. You have a planet with ice deposition, you have a planet with ice deposition, and here also ice deposition. But in contrast, 4 times 1, 2, 3 and 4 times in past 500 million years, the earth has seen a ice free planet, and also similarly 4 times the earth has seen a planet which has major ice house periods, right. So, this is a warm kind of a major ice house periods have been the major polar continental cells. So, current climate is in a warm phase within a ice house period. Now, if you come here 65, 60 onwards, you see the curve has gone down, down, down and down. So, that means we have currently have a period which is close to or within the ice house period. So, the take home message from this slide is nothing to worry, history always gets repeated. So, this is what history teaches us, that is why we study history. So, you see Earth's average surface temperature has fluctuated evidently. So, the word evidently I have introduced here, because that is why we have plotted 500 million of years, because we have taken the evidence, the clue from different experiments, different kind of observation, geological, be it ice core and other things. So, Earth's average temperature, surface temperature has fluctuated between 10 to 30 degree, and 4 times it has met with ice house or the hot houses. Okay. And then current one is more towards or is in a warm phase within the hot or within the ice house period. So, currently we are within a ice house period, but it is a warm phase of the ice house period. So, now please let us move from here onwards, that means it on a larger depiction. Here it is 65, let us see next is our 60. Okay. So, 60 then 65, 60, then we are coming closer to the current one. So, friends, we have put it here, look at this slide, very carefully try to observe it. This is a 60. So, that means 60,000 is 60 million. I have mentioned 1 lakh, 10 lakh is 1 million. So, it is 60 into 10 into 1 lakh, right. So, 60,000 years, 30,000 years, then you have a break, then you have 20,000 and it is the current one. That is what is the depiction as far as the year goes, that is shown in our x axis. Now, coming to the y axis, in terms of the y axis, a very important point I am going to mention here is, look at this, when we compare or we say that 1 degree or 2 degree temperature rise, that is always taken in comparison to 1850 and 1900 average. Look at here. So, global surface temperature relative to 1850 and 1900 in terms of degree centigrade, that is the benchmark. So, we need to know the absolute, then we need to compare it, and then we say that how much is the temperature rise or fall. So, why 1850 to 1900? Because that is considered as the pre-industrial area, and from there onwards lot of industrial revolution has started, and lot of emission of greenhouse gases or greenhouse gas loading to the atmosphere has happened. So, that is why always in terms of comparison we take the 1850 to 1900 as the average of 1850 to 1900 temperature as the benchmark, as the base data for comparison. So, now you see this scale in the y axis goes from -5 to plus 20 degree centigrade. Now, I will come back. If you see this is 10 to 30 degree centigrade, and here this is plotted with respect to global temperature in terms of past 60 million years. This is a type of relative. Okay. Here in this it was absolute. You see 10 degree to 30 degree, it is absolute. Here I am going to talk this slide talks in terms of relative. So, in terms of relative, it is saying -5 to plus 20. Okay. So, if you see with respect to this, when it has come below this, that means you have lot of ice deposition, and this is a kind of ice house kind of situation. And more importantly, you see all this pattern and how the back data also matches in terms of modeled and backcasting. You say when you try to simulate the past things, and then you have the reporting by different authors or different groups after doing their analysis also shown in terms of different colors. But importantly, when you study these kind of graphs, this kind of pattern, you must try to understand that in general the pattern or the trend is matching. So, the trend is fluctuating, within minus 5 to 0 here, between 1 lakh to about 20,000, and here also everything is coming down from 60 million years to about 1 million years. Now, please move to the third part. This is what is more important. The important point here is, you see, since last 20,000 years or 20,000 years back, our Earth's temperature was less than what you say, this curve you can see 3.5 or 4 degrees centigrade with respect to the average, and now you see in 2020 and this curve this is actually going up. Okay. So, now on this part we are going to discuss more and more. Now friends, the point or the take home message from here is try to understand or try to listen it very carefully. Look at the time frame here. This is 60 million years, and look at the time frame here in terms of rise of temperature. Just within 50, 60 or 120, 125 years, this temperature has gone beyond 1.1 degree within 125 years, 100 plus years. Okay. But here this fluctuation takes millions of years. This fluctuation is taking in terms of hundreds or decades. That is the cause of worry. So, the take home message from this slide is, or this particular discussion is, that the rate of rise of temperature or temperature rise is the cause of worry, or is the worrisome factor for us, for the humanity. Now, again the dissection in larger time frame. You see, this is minus 10,000, minus 1,000, then 1900 to 2000. Friends, this is the very current situation, and if you see here again, there in the past slide, the variation on y axis was taken from minus 5 to plus 20. Now, in the current situation we are taking minus 5 with here is 0 to 1.5. Okay. So, here it is a very immediate with a short time span. If you are seeing here between minus 10,000, here it is 2020 or 2050, let us say. Now, this pattern you see, and look at the pattern towards the end of 1950 onwards, or you see 1900s onwards. So, 1900 onwards, this up to this, or you say up to 1950, the trend has been very clear. The increasing trend in terms of temperature rise is very clear, but then the trend is clear, but trend is very high. The rate of increase is very high. This is what is the take home message or the realization from this slide. So, over last 50 years, the global temperature has increased at an unprecedented way. Why we are saying that it is not the precedence, it is in an unprecedented way. It is not in a regular way. The regular way is very slow rate of change. The unprecedented way, what we are saying, is the very fast rate of change, which is in comparison to the last 2000 years. So this has never happened in last 2000 years with respect to this trend of rise in the global average temperature. So this is important. The important point here is the rate of change as far as the average temperature is concerned of Earth. So, this is what is the cause of worry, and the latest decade was warmer than any multi-century period, which is represented here. After the last interglacial things, over the last 50 years, global temperature, as I mentioned, has increased. Friends, let us now have a differentiation as far as the land and ocean. First, look at the upper right curve, where we are going to discuss or the depiction is with respect to the temperature have increased faster over the land than over the oceans. If you see here, in terms of average it is 1.1, but if you take it up to 2, this is observed data, and this data is there up to 2018 before the report was compiled and published. So, when it has been dissected that over the land surface, that means the average surface average temperature rise over land surface is about 1.59, whereas over ocean it is about 0.88. So, that means the land is warming at a higher rate than that of the ocean. And look at the pattern, these are the fluctuations, and when you take an average, you pick the average trend, the trend is on rise. Now, down below on the right hand side, you see this is another two are there, one is the annual and decadal average, and the last one, the extreme below is a kind of decadal comparison. So, you can see that every current decade is warmer than its previous decade. So, this is what is the take home message here, is that land is warming faster than ocean, and when you take the global average, particularly the oceanic average is contributing towards bringing down the figure from 1.59 to in an average of 1.1. Now, look at the left hand side figure. These two are very important in terms of giving us a message that the temperature rise or variation or fluctuation over our surface is not uniform. It is different, or it is different over different places and different surfaces. You can see the upper one is for 1900 as during 1900 to 1980, and the lower one is between 1981 to 2020, and the scale is from the dark blue is between -8 and the dark red is up to 0.8, that is plus. And you will very well see that during the last decade 1900 to 1980, there are very slow rise, you can see from somewhere, and at places there have been cooling also. But in comparison to 1981 to 2020, that means the last 4 decades, you can see the temperature, the average temperature has warmed, and at many places, and particularly towards the northern pole, it has gone up to 0.8 degrees centigrade. So, that is what is very important to understand and observe. Now, in terms of the surface air temperature rate anomaly relative to 1850 and 90, you can also try to interpret in that way. So, in conclusion, what we discussed? We discussed these 6 points. The first point is loneliness in galaxy is helpful. We understood you can counter, had it been closer to the center, then perhaps our planet would have been hotter than what it is. So, that is why the loneliness or being at an edge in the universe is helpful to maintain a temperature what we are having now. Second, the presence of greenhouse gases. The greenhouse warming contribution in terms of Earth's rising temperature is about to the tune of 33 degrees centigrade. So, we need greenhouse gases. Had greenhouse gases not been there, Earth's average temperature would have been minus 18 degree or around that. So, we are lucky that we have greenhouse gases, but we need to maintain the greenhouse gas concentration, the one which is needed, and more than that is actually contributing towards warming. And in the sense we have started receiving warming, as we mentioned, as we have seen more severely since last 4 or 5 decades. So, global mean temperature has fluctuated between ice house and hot house conditions in past 0.5 billion years. Global surface temperature in terms of degree centigrade relative to 1850 to 1900, we have seen it is the variation pattern, and this 1850 to 1900, the average of 1850 to 1900 is taken as the benchmark to compare and contrast in terms of rise in Earth's temperature, because this coincides with the era of pre-industrial era. Over last 50 years, global temperature has increased at an unprecedented way. So, this was not a precedence before, it was not a regular phenomena before, but we saw that in last 2000 years the temperature rise pattern has started, and in last 3-4 decades it has started rising very fast. The rate is very high, which is the cause of worry. The temperature have increased faster over the land surface. So, there is a disparity in terms of surface temperature fluctuation or the rise. So, over the land surface it is at the rate of 1.59, it is 1.59 degree centigrade in comparison to 1850 to 1900 average, whereas over the oceanic surface it is 0.88 degree centigrade. So, these are a very important understanding or benchmark to know that what is temperature rise, what is the temperature pattern in terms of past 500 years fluctuation, and then where do we stand. So, these all gives us a very good understanding in terms of the temperature fluctuation over Earth's surface or over our own planet. Thank you very much, friends, and please go to these references for detailed understanding, and thanks a lot once again.